Alright, here we go. We are looking now at regression, which is as easy as 1, 2, 3. Alright, so this is a new approach. Same formulas, but a new approach to regression. Alright, let's go. Let us go. So the goal in regression is to develop what we call a predictive equation, actually a linear equation, in the form y equal a plus bx, where y is what we call the dependent variable. That's the one that we want to predict, the one we want to learn more about. A is the y-intercept. That's where the line touches the y-axis. B is the slope of the regression line. And x is the independent variable. That's the one that we're using to do our prediction. So graphically, it looks something like this. So A would be where the line touches the y-axis, and the slope of the line, which we could find as rise over run, right? Change in y with respect to x, that is B. All right, so let's go. So the starting point is that we have to have historical data. Right? Without historical data, we are unable to do anything with regression. Right, so here we have let's call it 5 months of data, and the figures are all in thousands. So the first thing we have to do is identify which of these is our dependent variable y. Is it advertising or is it sales? Now, of these two, advertising, we decide on our advertising budget, right? But when it comes to sales, we have no control over that, and we want to learn as much as we can. So sales will become our dependent variable, and the independent variable would be advertising. Right, so the dependent variable, the one that we want to predict, right? Independent variable is the one that we use to do the prediction. So in this scenario, dependent variable is sales, independent variable is advertising. So here we have some formula, looking kind of technical. And this is what exists now for regression, right? But what we say is to make it as easy as 1, 2, 3, we break these up into pieces and we take them in smaller bites, which are easier to consume. So here we go. So we have equation 1, right? N times the summation. This little sign here means summation or total of whatever is here. So this is the total of the x times y values minus the sum of the x values multiplied by the sum of the y values. Now at a glance, this looks like, if you're pronouncing this in English, right, you're saying it looks like nexy xy. So that's how many people try to remember this formula, nexy xy. And that's formula number 1. Now, once you know this first formula, the others are easy to know, because the second one says we don't want y, we only want x. So in the second equation, we replace y with x. So x times x becomes x squared, and summation of x times the summation of x becomes summation of x all squared. So equation 2, very similar. Once you know nexy xy, you can do equation 2, and then you can also do equation 3, which says don't give me x, just give me y. So instead of x squared, we have y squared, and instead of summation of x all squared, we have summation of y all squared. So this is the easy as 1, 2, 3 method, where we break down the complex formulas into simpler bits. Easier to throw on. Then our formula for the slope becomes equation 1 over equation 2. And the formula for r becomes equation 1 over the square root of equation 2 multiplied by the square root of equation 3. For formula purposes, it probably helps to put a bracket around the terms in the denominator for calculator purposes. Right? It helps. And the last formula is A, which is just a summation of y minus b times the total of x over n. Of course, there are other versions of the formula for A which work just as good. Right? There's a formula that says the average of the y values minus b times the average of the x values. That works just as good. Right? But we'll stick with this one for now. So, formula 1, nexy xy. We need the sum of the xy values. So for each row, we're going to have to calculate the value of x times the value of y. So here goes. So row 1, 10 times 84, 840. 18 times 155, 2790. 35 times 320, 11,200. 42 times 388, 16,296. And then 55 times 412 is 22,660. And of course, we want the total, so we just add them up. Right, total of all these, 840 plus 2790 plus 11,200 plus 16,296 plus 22,660. And I'm getting a total of 53,786. We also want the total for x and y, so we put those totals as well. Alright, so we have our xy, and we have enough now to calculate equation 1. So equation 1 says n, which is the number of results. So 1, 2, 3, 4, 5. So n is 5. So 5 multiplied by the total for xy, right, 53,786, minus total of x times the total of y. Punch that in the calculator, we get 51,490. And we now have a value for equation 1. Right, remember, easy as 1, 2, 3. So 1 down, now onto 2. So for 2, right, for 2 we want the summation of x squared. So we need another column for x squared. Right, so in the first row, 10 squared, that's 100. 18 squared, that's 324. 35 squared, 1225. 42 squared, 1764. And 55 squared is 3025. Total of which is 6,438. So we can now complete equation 2. Right, so it's going to be n, which is 5, times the total for x squared, 6,438, minus the sum of x, which is 160 all squared. Right, punch that in the calculator, we get equation 2 is 6,590. So we can now move forward, because for the slope of the equation, all we need is equation 1 and equation 2. Right, so we now have enough to calculate a and b. So we'll start out with the information we have. We haven't done equation 3 yet, so let's leave that as question sign. So b, equation 1 over equation 2. So for b, we're going to have 51,490 over 6,590. And that gives me a value of 7.8. So b is equal to 7.8, rounding to 1 decimal. A is equal to the sum of y minus b times the sum of x over n. So the sum of y, 1,359 minus b, 7.8, times the sum of x, which is 160, all divided by n, which is 5. And that works out to 111. So we now have a is equal to 111, b is equal to 7.8. So we can write our equation. Y is equal to a plus bx, means y is equal to 111 plus 7.8x. Now for r, we need equation 1, 2, and 3. So far, we only have equation 1 and equation 2. Right, remember when you're doing this, just put brackets for the denominator. Right, it really helps. But let's do equation 3. So we're going back to our table. Right, and equation 3, n times the summation of y squared. So we need the figures for y squared. So let's go. So 84 squared is 7056. 155 squared, 24025. 320 squared, 102,400. 388 squared, 15544. 412 squared, 169,744. And the total of these y squared values is 453,769. So we're now ready to find equation 3. So equation 3 will be 5 multiplied by the total for y squared, 453,769, minus the total of y squared, 1359 squared. And that gives me 421,964. So we now have equation 1, 2, and 3. Right, so by equation 1, 51,490. Equation 2, 6590. Equation 3, 421, 964. We already found B was 7.8. And we already found A was 111. So now we want equation for R. Alright, or whether equation Y equal 111 plus 7.8x. So R now, R is equal to equation 1 over square root of equation 2 times equation 3, square root. So that's equation 1, 51,490 over square root of equation 2, so square root of 6590, multiplied by the square root of equation 3, which is the square root of 421,964. As said earlier, for the calculator purposes, just put a bracket around the denominator. So you'll now be saying 51,490 divided by, open brackets, square root of 6590 plus the square root of 421,964. Alright, and let's see what that gives us. It gives us 0.98 for R. So we now have Y equal A plus BX, we have A and B, and we now have R. So let's go to some interpretations. So for the slope, right, the slope is B equal 7.8. How do we interpret that? We are saying each time the value of X increases by 1 unit, Y is going to increase by 7.8. So watch this. If X is equal to 1, then Y is equal to 111 plus 7.8 times 1. So that's 111 plus 7.8, which is what? 118.8. If X is equal to 2, right, Y will be equal to 111 plus 7.8 times 2. Right, 7.8 times 2 is 15.6. So that's going to give you 116.6. Actually 126.6. Right, so X increased by 1 and Y has increased by, what's the difference there? So it's 126.6 minus 118.8. And the difference is, of course, 7.8. If we move up to 3, X equals 3. Y will be equal to 111 plus 7.8 multiplied by 3. And that gives 134.4. Subtract from that the previous value of Y, 126.6. And we get a difference of 7.8 again. So of course, each time the value of X increases by 1 unit, the value of Y will increase by 7.8 units. Right, that's a general relationship. If you want to get more specific, right, we'll use the terms that exist. So since the unit of measurement for both values, both advertising and sales, is in the thousands, right, meaning 1 unit represents $1,000. For the interpretation, would say for each additional $1,000 spent on X, which is advertising, the value of sales will increase by 7.8 units, which is $7,800. Alright, so that's the interpretation for the slope. For the intercept now, the intercept is 111. Right? Now, again, we would say, if no money is spent on advertising, the value of sales would be 111,000. Because what we're saying here is X equals 0. Right? You're left with 111. On the graph, how that would look. Right? So your y-axis, your x-axis. I was saying this here, the intercept, the part where it touches the y-axis, the value there would be 111. Right, that's how we would show it graphically. All right. Continue a little bit more. The correlation coefficient R, we got 0.98, and it measures the strength and direction of the linear relationship between the dependent variable y and the independent variable x. It is measured on a scale from -1 to +1. -1 indicates that there is a perfectly negative linear relationship, right? So they move in the opposite direction. If one goes up by 10%, the other goes down by 10%, right? So a perfect one-to-one relationship, but in opposite directions. 0 indicates that there is no linear relationship between the two variables. And +1 indicates a perfectly positive linear relationship. That means that they move in the same direction. If advertising goes up by, or if X goes up by 10%, Y will also go up by 10%. Right, that's for +1. Now, these are really extreme because you usually don't find perfectly negative or perfectly positive relationship. Right, but they are benchmarks for reference. So in this case, the first thing is, if it's a negative number, we say that it's a negative linear relationship. If it's a positive number, we say it's a positive linear relationship. So R equals 0.98, that's a positive number. So we would say that this, for R equals positive 0.98, right, it says that there is a positive linear relationship between advertising and sales. Then the number now, so the sign, negative or positive, tells you the direction. The number itself now tells you the strength. The closer it is to 1, whether negative or positive, the closer the number is to 1, is the stronger the relationship. So a number close to 1, a strong relationship. A number close to the middle, which is 0.5, is a moderate relationship. And a number close to 0 would be a weak relationship. Alright, so for this one, 0.9 is very close to 1, 0.98. So we would say that this is a strong relationship. The number is positive, so say it's a positive relationship. So for R equal 0.98, we see that there is a strong, positive, linear relationship between advertising and sales. Right, so a strong, positive, linear relationship between advertising and sales. Last but not least, we have our coefficient of determination, R squared. And R squared measures the percentage of changes in Y that can be explained by changes in X. Right, so it's telling you how well the independent variable is predicting the dependent variable. So all we do is square the value of R. So R equals 0.98, which means that R squared is 0.9604. Expressed as a percentage, just multiply by 100, that would be 96.04%. Alright, so how do we interpret this? Interpretation, we say 96.04% of changes in Y can be explained or attributed to changes in X. Alright, so 96.04% of changes in Y can be explained by changes in X. Of course, we know X and Y, so we can name them. So we say 96.04% of changes in sales can be explained by changes in advertising expenditure. Alright, and that takes us to the end of our regression. Easy as 1, 2, 3. So keep practicing and let me know how this helps you. Alright, blessings and take care.